All right, guys, let's start off with the first Sunfounder lab. So we're going to start off with the LED controlled by a push button. So you may have watched some of the previous videos of mine, or you've started in on Paul's playlist, but we're also going to do the labs that are within the manual that came with your RFID kit version 2 for Arduino. So that lab or the manual is actually online as well. So if you go to www.sunfounder.com, so that is right here. Then you go to Learn. So this drop-down menu, you're going to click on Get Tutorials. That brings you to this page right here. And it looks like they have a number of different kits. So we should look at the different kits and decide which one is better than the other. But the one that we've seen so far is really good, the one that we've purchased. So let's go to RFID Kit version 2 for Arduino. So we'll click here. Right on. So this will probably already be on the image for your computer. So I've probably already downloaded it and placed it on the master image for each of the computers in the lab. So if it's not there, you can download it. But essentially, everything should be there. I believe this is all the code that is embedded in each of these 30 different lessons here. So awesome, eh? There's 30 different labs that we can do with the stuff that we just purchased, plus all the stuff on Paul McWhorter's playlist. So let's start off with this guy, Lesson 1, control the LED by a button. So we'll click on this guy, right on. And this is the exact same wording as you'll find in your manual. So what do we need? We need the Sunfounder Uno board. So again, this guy right here is basically the same as an Arduino Uno. It's just made by Sunfounder. We need the USB cable, which is already hooked up. We need one push button. We need a 10K ohm resistor. We need some jumper wires, and we need the breadboard. Okay, so this breadboard is that came with the unit is quite large for the plastic housing that they have here to put the Arduino on. So what I did was I just cut on the back. I cut the tape off of the stickum and just stuck it onto the plexiglass here, and it seems to be working quite well. But just line it up. I didn't get it perfectly, and it's bugging me that it's off by a touch, but it is basically welded onto the plastic once you stick it on. Okay, so we need a 10K ohm resistor, and we need some jumper wires, and we need the breadboard. Right on. So this shows us that on the push button that these two bad boys have continuity and these guys have continuity. So what we don't want to do is we don't want to connect it up down here, because by placing it here, then we may short out portions of the switch, because remember that from here down, all these guys have continuity, right? So rather than shorting out the switch, what we'll do is we'll put it across this, so we know that there's no way that this and this have continuity. So we'll push her in. I need to give it a little bit of push to get her to go in. Careful when you take it out. Don't reef her out, because the pins will shear, and then your push button is useless. Okay, so that guy is in there. And oh, sweet, it's got a fritzing diagram here as well. So there's our push button that we've just placed in there. We need a jumper. Looks from pin 12. We're gonna have a jumper over to one side of the switch. Okay, so let's do that now. They got a blue conductor there, so let's keep the same color coding as they've got there. Okay, so we need a jumper from terminal 12 over to our switch. Okay, so just make sure that it actually lines up with that line for that terminal on your switch. And we need to go to terminal 12, and let's see, that's on analog in. Okay, so where's analog in is down there. Okay, it looks like we're oriented the same. So this guy's got to go to pin number 12, 8, 9, 10, 11, 12, right on. Okay, so that guy's there. And what else do we need? We need a jumper between ground and the board. So let's put another jumper in there. They got a black connector, which I don't have. Okay, so whatever, we'll take this green right here, and we'll go from the board. So we're going to use one of these guys, and we're going to go to the ground. So the ground looks like 13, and then ground is right here. Okay, that's good. Then we need the 10K ohm resistor. And where does the 10K ohm resistor go? It goes in the same line and ties into that one that we just tied into ground. So let's put that guy right there. Okay, that feels like it's in there. And let me try and get my fingers out of the way. And that guy is going to go right there. Okay, cool. Do you see that? Once you put the pull down resistor in there, then the LED went off. So see how the LED is already firing on there? So we don't want that. So LED I'm looking at is this guy right here. Can you guys see that? So that LED right there is on. And as soon as I connect up this pull down resistor, then it turns off. Beautiful. Okay, so that's what that resistor is. So again, you can see that the light turns on, and once I put the resistor in there, then it turns off. Sweet. Okay, so now we don't have the LED turning on for the wrong reason. We want the LED to turn on once we send the signal into our Arduino. Okay, so on the other side of the switch, of the push button, we're going to go from there, and we're going to feed that with 5 volts. Okay, so we're going to go to here, right? So that's our switch, and we're going to pick up the 5 volts. And where's the 5 volts? Hard to see with the camera here. I think that is the 5 volts right there. Let me just stand up so I can actually see. Let's see, IO reference, reset. Wow, that's really hard to see. V in, ground, 5 volts. Yes, is that good? Yeah, she's nice. Okay, excellent. Let's get this guy out of the way so we can see what we're doing. Beautiful. Nice. Okay, so I already have the code in there from before. So let me show you where I grabbed the code from. So hopefully you're cool on the wiring there. So you can go to the manual that you're looking through, or you can go to this page and take a look at the fritzing diagram there. And hopefully you saw the same thing with the pull down resistor, that the LED was turning on without it. And let's just make this a little bit smaller here. Cool. So there is our diagram there. So they have a wiring diagram of the Arduino Uno. And it looks like we're going from the 5 volts over to our push button. And then from the push button, we're going into input number 12, digital input number 12. And then we have this pull down resistor that comes over here and ties into ground as well. Beautiful. Okay, so next thing we need is the code. So let's scroll down here. Okay, so we're already there. So because it says go to get the tutorials. So we'll do that later on. But right down here, isn't this awesome? Everything's all on one page. This is mint. So the code is here, and even though I'm redoing the video, they have their own video here that you can watch. Okay, so but I want to learn this at the same time, so I'm going to I find the best way to learn it is to do a video. So what we're going to do is we're going to grab all of the code here. So rather than like writing it down, then we can just copy and paste it in. And let's drop that into our Arduino IDE now. So let's drop that guy into here. Okay, so what you might want to do is you may want to actually take the time to physically write this down, right, in your notebook. So you should have a notebook that as you're going through each of these different programs, and you're going to write this down as we go through, and then you're going to copy and paste into your Arduino IDE, or you're going to just physically type it in like as you see it. Okay, so let's delete this guy out. Let's open this and let's drop that in there. So we'll paste there. Beautiful. Okay, so let's start off at the top and see what they've got in their program. So these first two lines right here, so these dash lines here, are there just for comments. So if you put 2 dashes there, then each of these guys will just be a comment, and the Arduino will not look at this for any code or anything like that. Okay, so we have the name controlling an LED by a button. Then it tells us exactly what it does. So it turns on and off an LED when pressing the button attached to pin number 12. So when pin number 12 has 5 volts applied to it, then the LED is going to fire on. Could we do this without the Arduino? For sure we could. I mean, we don't really need an Arduino to have a push button turn on an LED, but we're building up the code, right? So it's just one step towards mastering everything in electronics. So next thing is they've got their support, then the website, so you can purchase their products, and then the date, and then you may want to put in, like if you're doing different sketches and stuff. So your program, I'm going to now call a sketch. So different sketches, you can have the date, and then you may want to put in revisions, right? So revision, come on, Pete, revision 1, right? So then you know if you're building something up, then you can keep track of each of your revisions. If something worked before, and then you added something in for revision 2 or 10 or 12, you can always go back to the previous save. Okay, so what we're going to do first is we're going to create a constant in that it's going to be an integer, and this guy right here, key pin, is now going to be the same as pin number 12. Right, so we're going to see that down here we're going to make use of key pin, right, instead of pin number 12. Maybe we want to change the pin around, right? Maybe we want a different input there. So rather than using 12, we use a different input. Well, we can just use key pin, which is just a kind of like a global variable there, and then we're just telling it which pin corresponds to that. Okay, so we're creating two integers here. The key pin and the LED pin. So the LED pin is going to be pin number 13. And what we'll find, or what we've already found, is that pin number 13 is connected up to the LED on the actual Arduino Uno. So that LED that fires on right there, so this guy right here, is tied in with pin number 13. We can also hook up an LED, an external LED, but when we're firing on 13, we're essentially turning on that LED there as well. Okay, so what else should I mention here? So these are, again, comments saying the number of the key pin, the number of the LED pin, and then you'll notice that at the end of all of these lines, there is the semicolon. So the semicolon allows it to go, kind of tells it that it's the end of that statement, and then moves on to the next line there. Okay, these guys are just stars to show you different portions of your program, but again, they're just showing you a comment there. Okay, so the first thing you start off with the Arduino IDE is your void setup. So this is the first portion of your program. So that sets up the environment that you're going to be doing your code in. Okay, and then down here you can see that we've done the pin mode. So the pin mode is telling us that key pin, which we associated with input number 12, is going to be an input. So that initializes the key pin as an input. So you'll see that the input is blue, okay, and the output is blue. So essentially what we're doing is we're taking this string right here, this string of letters here, key pin, and key pin is now being initialized as an input. And over here, we made it the fact that key pin was associated with the integer number 12. Okay, again, for pin mode here, we're putting pin mode space, then brackets LED pin. So this is just the name that we've given that guy. Then we have a comma, and then we have output. Okay, then you close the brackets, and then to finish off the statement there, then you have your semicolon. After that, you have the two slashes there, and then your comment. So that line right there initializes the LED as the output. Okay, you'll notice that you have this guy and this guy, so that closes your void setup there. So it starts at that parentheses and then finish at this parentheses. And then down below, this is going to be your loop. So this is like your on your PLC, the scan that's going to happen. So it's going to scan from here and then go all the way down throughout your program. Then come back up to the top, right? Start the void setup, set up your pin modes, and then do this loop again. Okay, so right here again, we have the parentheses to start off. So we have void loop, the two of these guys. Can't find the words today, sorry. Two of your brackets there, and then you have your parentheses, and then it looks like we have some comments down here. So it says read the state of the key value and check if the key is pressed. So the key is basically the push button, right? So we got the push button, and we're going to see whether the push button is pressed. Okay, nothing in these lines corresponds to our program. Again, this is just a comment. Okay, if it is, the state is high. So remember that there are two states to any Arduino, or any two digital states to any Arduino, and that would be, in this case, 5 volts or 0 volts. 5 volts is corresponding to high, and 0 volts is going to correspond to a low. Okay, so if we say if digital read, so if we read the digital input in the key pin, which we said, which was an input up here, if it's equal to a high, then it says digital write. So digital write means that you're going to turn something on. So here you're reading a digital input. Here you're turning on a digital output, digital meaning on or off, high or low. And in this case, it's saying to make LED pin high. So that means turn it on to 5 volts, right? And once the 5 volts goes out, then the LED that in this case is incorporated onto the board of the Uno, that's going to fire on when that 5 volts is applied to it. Okay, once we're done, then we have the closing of the parentheses, but it looks like they have an else statement. So this is like if this is true, then do this, else, right? So there's your if statement up here. So if the digital read is high, then write a digital high to that LED pin, and that LED pin was 13. Okay, so make 13 go high, or have it turn on 5 volts. Else, then digital write LED pin is low, right? So as long as the digital read is high, then turn on the LED. If anything else is happening, right? So this says if anything else is happening, then fire on a low for the LED pin. So bring it back down to 0 volts. And in this case, they have the comment here telling us that it's going to turn off the LED. Okay, remember to close your parentheses on everything. Then below, do we have anything else on the bottom? No, that's it. Just have this final line to show us that we're at the end of the program there. So what we're going to do is we're going to, you can save this if you wish. Essentially what we're going to do is we're just going to verify. So this is similar to in the PLCs when you're compiling your program. So we're going to verify this guy. So we'll click here. Oh, it's asking us to save it. So we'll save it to our Arduino libraries. Okay, and you can see that it is compiling the sketch here. And it tells us how many bytes it's using. Global variables use 9 bytes, 0% of dynamic variable, yada, yada, yada. And it looks like everything's good, right? Does it say anything about errors or anything like that? No, no comment whatsoever. Everything is good. It just says done compiling and there's no errors. Everything seems cool. Okay, so the next thing we're going to do, because we already have our USB cable connected into our board, is we're going to download this guy. Or I think this is actually upload. Yeah, so we're going to upload this to our board. So in PLC language, it's download. In Arduino's, it's upload. So we're going to upload this to our board now. So we'll click here, and you can see that it's looking for a serial port. So over here, let's hit cancel for 2 seconds. Over here with the tools, you can tell it which board it is. So we're using an Uno board. Okay, so make sure that you've selected the appropriate board. And when we go to upload this guy, then it's going to look for a COM port. Looks like it's found the Arduino is connected up, in my case, to COM port 3. So that's great. So I'm going to hit OK. Excellent. So it's compiling the sketch and then uploading, and then it's done uploading. Right on. So that same program was already there, but we should see that now that if we press this push button, that the LED fires on. Right on. Excellent. Okay, again, if we don't have this resistor in, then the LED fires on just with interference. So we want to put that pull down resistor there. And now the LED is being turned on by the actual Arduino board. So it's looking at the signal going in. So we have our 5 volts applied to the push button right here. We have this blue going into input number 12. And then we said that pin number 13. So that's kind of cool, and that you can actually decide whether these pins are going to be an input or whether they're going to be an output, right? We did that right here. So we decided which pins were going to be an input and which ones are going to be an output. So from pin number 13, that guy is now firing on the LED that's integral to the board there. And the reference to ground is right here. Sweet. Okay, so nothing crazy about this one. Hopefully everything worked out with this lab. Let's do one more thing though, just to show you how to fire on an actual LED that's external to the board there. So we know that the 13 is firing on, right? So let's have 13 go out to our breadboard. So let's take this guy and let's connect it up somewhere different on our breadboard there. And then from there, let's connect up our LED. So I'm just going to throw the LED in, and I'm going to put one side to what I know is ground, and we'll see whether it works. Oh, she's tight. Come on, buddy. Why is that not going in? There we go. Okay, so she's in. Let me get my fingers out of the way in 30 seconds. Okay, so I did not see the polarity that I put that LED in. So we're going to see whether it works or not. If it doesn't work, then we're just going to flip the LED around. Okay, so let's now fire on our push button now. Hey, sweet. Right on. So there is the LED turning on. Okay. If it didn't turn on, then you don't have the polarity right. So just quickly do a Google search for the LED anode cathode diagram, and you'll see that the shorter end is the negative and the longer end is the positive, right? So I could have had this in backwards. And if I don't give the LED the correct polarity there, so you have to make sure that it actually engages with the pins on your board here. Otherwise, it's not making continuity. But here you can see that the LED on the board is turning on, but the LED that's external is not turning on. Now, if I flip this around, then it should work now. There we go. That guy going into the negative is being a pain in the... Come on, man. There we go. Okay. Beautiful. Right on. Okay, now the other thing that I want you to notice is the LED is super bright. Okay, I don't know if it's coming out on the camera as super bright, but it is super bright. We're supposed to be putting a resistor in line with that LED. Otherwise, eventually we're going to smoke it. So I'm actually going to move this one up here, and I'm just going to grab any resistor. So it really doesn't matter what resistor I'm grabbing. The resistor will essentially decide how bright the LED is going to be. But I just want to make sure that I put a resistor in series with the LED, so it still turns on, but it's not going to smoke. So the resistor is now limiting the current to the LED, and it's better practice to make use of that resistor. Do I know what the resistance value is? No, I don't really care at this point. I just know that I'm going to, it's a decent enough. It's one of the values from the kit that I grabbed, but essentially it just limits the current to my LED. Sweet. So now we've got the basics on how to set up your pin mode, right? So we set up our pin mode there. Let's go back to our Arduino IDE. So we set up these guys right here on pin 12 and pin 13. Then we set up the fact that key pin was an input, LED pin was an output, key pin was pin number 12, LED pin was pin number 13. We now know how to put in our comments as well. We start off with the void setup. We close that parentheses. Then we go into our void loop. And essentially, it's just going to keep doing this loop over and over and over, right? In this case, it says if the digital read at key pin is high, so if it's reading 5 volts, then it says turn on the LED. So do a digital write to the LED pin and make it go high, go to 5 volts. Anything else, do a digital write, but turn the LED pin, which again is an output, and an output on pin number 13, make sure that it goes off or that we have 0 volts out. Excellent. Okay, hopefully everything worked out for you there. We now have like 30 different labs that we can make use of, right? So we go back one page here. Then we have a number of things. The next thing we're going to do is actually we're going to control, get out of there. We're going to control the LED with PWM, so with pulse pulse width modulation, but there's probably going to be a couple of videos before that of either mine or Paul McWhorter's building up some good programming skills, and then we'll get into the pulse width modulation. All right, guys, hopefully everything worked out. If you like this video, give it a like, and we'll see you on the next one. Thanks very much, guys. See you soon.